Welcome to lesson number 1. And in this lesson, we're going to be talking about angles and straight line and what their relationships are. Alright, so let me just draw a straight line here for you. Right? And the question says, I want to know, the question says the gradient of this line, let's say is 2. And the question says, I want to know what the angle that this makes, so this angle theta, I want to know what that angle is. Alright, so in order to find that out, I'm going to pick out 2 points. I'm going to pick out this point here and this point there. I'm going to make another right angle triangle, like so. So using this right angle triangle, we're going to find out how to find the area of the angle of theta. So using this this right angle triangle, we're going to find out the value of theta. Well, last lesson we learned that this triangle has two properties, the rise and the run. Rise and run, right? So the rise side, if you remember trigonometry, we had ka, toa. Remember that? That was just a quick reminder of trigonometry. So from this angle, we have, what sides do we have? We have the opposite side, and we have the adjacent side. So if you have opposite and adjacent, which ratio do we use? We use tan. So we know that tan theta is equal to opposite, which in our case is rise, over the adjacent, which is run, right? We know that tan theta is rise over run. So hang on, last lesson we discovered some relationship. What is rise over run? Well, rise over run is actually, we know that it's a gradient. And this is the equation we're going to use to solve this question, right? So this is the equation. We know that tan theta is equal to gradient. So this is the equation we're going to use for this question. So to find the angle, we know that tan theta is equal to, what's our gradient? Now gradient in this case, the question is telling us is 2. So how do you solve for theta? Well, you remember trigonometry, you take tan to the other side by doing tan inverse of 2. So then you would type that into your calculator. So once you have a go, if you have a calculator with you, if not, I'll just do it quickly. So I want to know what tan inverse of 2 is. Tan inverse of 2 is 63 point, let's say 2 decimal places 43 degrees. All right. So that's basically all I want you to understand from that little part is the formula, which is tan theta is equal to m. All right. So let's do a proper question. A line passes through the coordinates 7 and -3 and 4 and -2. So those are 2 coordinates. I want to know what angle, so the angle that the line makes with the positive direction of x-axis. Okay, let's dissect that in a second. So what I'm going to do is actually plot both of these coordinates out on my graph. So I'm going to draw axes. I'm going to plot both these coordinates out. -7, -3 is roughly here. -4, -2 is roughly there. Right? And they're saying that this line passes through both these coordinates like so. Let me try better. There, something like that. So that's the line. And I want to know the angle that this line makes with the positive direction of x-axis. So this angle here, theta. So I want to know, so positive direction means the right. So you have 2 angles that it makes with the x-axis. One is this massive obtuse angle, which is alpha. And the one on the right is theta, which is the positive direction. So using an example we did here, this is in the positive direction of the x-axis. Over here would be the, let's say this alpha, that would be the negative direction of the x-axis. So positive direction is to the right. All right. So we need to find theta. How are we going to do that is use our equation. We know that tan theta is equal to m, right? So what is the gradient of this line? Well, we learned it last lesson, right? If we have 2 coordinates, we can use the equation y2 minus y1 over x2 minus x1 to find the gradient. So let's do it. y2 in this case, let's say y2 is -2. So -2 minus -3 is y1. So minus minus, remember? And then we have x2, which is -4 minus -7. So let's get the gradient now. M is equal to -2 minus -3. -2 minus -3 is positive 1, sorry. So it's +1 on the bottom, +1 divided by -7 plus 7, or -4 plus 7, which is 3. So 1 over 3 is our gradient. So we can say tan theta is equal to 1 over 3 because 1 over 3 is our m value. And theta is equal to tan inverse of 1 over 3. So theta is equal to, well, you need to type that into your calculator. Tan inverse of 1 over 3 is 18.43 degrees. Okay, so that's just the calculator thing. Right, so that's one question. So now let's look at the other way around. So this time, the question is telling me the line makes an angle of 45 degrees with the positive direction of x-axis. Find the gradient of this line. Well, this time, the question is giving us the angle and asking us to find the gradient, so the opposite way. So let me show you what I mean. So let's say you got a line here. Now it's saying that this angle here is 45 degrees. So it's giving us degrees now. So well, it's still the same equation. The equation is tan theta is equal to m. So instead, this time we have theta. So we have tan of 45 degrees is equal to m. Type that into your calculator, you'll get 1 is equal to m. So m, our gradient is 1. Simple as that, guys. That's our answer. All right, let's keep going. So this next case is a bit special. Negative gradient. So same question. So the question is saying, okay, my gradient is negative. Okay, but then the question is asking what is the angle that it makes with the positive direction of x-axis. So you might think it's the same process. So let's have a look. All right, so we know again our equation is tan of theta is equal to m. Right? What is m? That's the equation. So m is going to be negative 2. So then theta is equal to tan inverse of negative 2. Right? Why don't you guys type that into your calculator and see what happens? What you guys are going to get, all right, is negative 63.43 degrees, which is a little bit weird, guys. Why are we getting negative numbers? Right? An angle cannot be negative. It doesn't make sense, right? So let's talk about why it's negative, okay? This is a special relationship. So we're going to say if m is less than 0, in other words, if m is negative, okay, our gradient changes to this, the gradient formula. The formula is tan theta is equal to negative m, right? So it changes if my m value is negative. So let's plug it into equation and see what happens. So we know that tan theta is equal to negative, and what's our gradient? Gradient is negative 2. So negative of negative 2. In other words, you have tan theta is equal to 2. I hope you're with me so far. So then theta is equal to tan inverse of 2, which we found out last time was 63.43. So you can see the only difference was the negative sign between here and here. But at least now we don't get a negative angle, which doesn't really make sense, right? A negative angle can't really exist. So, but you guys might have noticed this cannot possibly be this angle because look, this angle is an obtuse angle. Obtuse angle is an angle that's bigger than 90, right? It's a fat angle. But we're getting over here 63 degrees, which is an acute angle, right? It doesn't really make sense either. So actually what I'm going to tell you is the angle, the 63.43 degrees, is this angle here that it makes with the negative direction of x-axis. So this angle over here is 63.43 degrees, right? So then how do you get the answer to the question, which is this angle? Well, theta is equal to, it's very simple, guys. Both of them are 180 supplementary angles, so they add up to 180. So to get theta, you do 180 minus 63.43. Right, so put that into your calculators and get the answer. I'll do it quickly. So 180 minus, make sure you're using all decimal places when you put into your calculator. So this would be equal to 116.57. If you use all decimal places, you get this answer if you round to 2. Okay, so that's how you deal with negative gradients. All right, let's do a question now. So a line passes through the coordinates negative 1 and 2. And negative 3 and 4. Find the angle that the line makes with the positive direction of x-axis. So again, let's sketch it out. Let's sketch out the coordinates. All right, let's see. So we have negative 3 and 4, which is roughly over here. And then we have negative 1 and negative 2, which is roughly over there. As you can see, it's a pretty steep negative gradient, this one. Right, so the line that goes through both these coordinates is something like this. And we need to find the angle that it makes with the positive direction of x-axis, which means it's this angle here. That's the angle theta, let's say, we need to find. All right, so again, we use the same equation we've been using this whole time. Tan theta is equal to m. Okay, so we don't know if gradient is positive or negative yet. Well, we can see from the graph it's negative. But let's find out what the actual gradient is first. So remember, m is equal to y2 minus y1. So 4 minus negative 2, y2 minus y1 over x2 minus x1 is negative 3 minus negative 1. So you're left with 4 plus 2 over negative 3 plus 1. So So 4 plus 2 is 6, negative 3 plus 1 is negative 2. So you can see the gradient of this one is a negative gradient. So if the gradient is negative, guys, we cannot use this equation. So what equation can we use? Well, we use the one I set up here. Tan theta is equal to negative m, because if m is less than 0, right? So we can say tan theta is equal to negative m. So then we can say tan theta is equal to negative of negative 3, because negative 3 was our gradient. So tan theta is equal to positive 3, negative is positive. And then you can say theta is equal to tan inverse of 3. Right, so type that into your calculators and see what you get. Have a go. So I'm going to do it. Tan inverse of 3 is theta is equal to 71.57 degrees. Okay, so again, remember this is an acute angle. 71 degrees is an acute angle. We're looking for obtuse angles. Remember, when you're doing negative gradients, the angle you get from the equation is the one on the left, right? It's the one on the negative side of the x-axis. So this is 71.57 degrees. So to get because the question is asking for positive direction, that's the angle on the right side of the line, we have to do obviously 180 minus 71.57. So use your calculator. Make sure you use all decimal places, otherwise you guys are going to get rounding errors. So if you do that, it's going to be, so this theta is equal to 108.44 degrees Celsius. Okay, so that's all the relationship there is between straight lines and the angles that they make. Okay, so main takeaway is this equation. So the main takeaway we understand is this equation, and the difference when you use the negative is when the gradient is negative. Okay, so I hope that all made sense. All right, rewatch the video if it didn't. I hope you got it. I'll see you soon.